Again, David Jansen from Jansen Audio. Again, a long history in the family of designing electrostatic speakers, and we're really glad to have him today. So I'm going to turn the floor over to David, but I would just like maybe, David, if you could just start out and talk to us about some of that history, because it's definitely, obviously really been important in the development of electrostatic speakers in general in audio, and obviously been a long time in the process. So if you could talk to us a little bit about that to get it started.
Okay, sure. Thanks, Tony. So, yeah, I'm David Jansen. I'm a son of Arthur A. Jansen, otherwise known as A squared. He invented the first practical electrostatic speaker for the purpose of testing hydrophones on a project he was working on for the Navy at Harvard in the late 40s. Well, starting in the mid 40s. By the time they got done, the war was over. But at any rate, there were no speakers that had good enough transient response to test these hydrophones that were going on these torpedoes that were supposed to home in on U-boat propeller noises. And so he did that, and then the war ended and the lab's work started to wind down, and he had this really cool high fidelity transducer, and he's like, this would make a great tweeter. So he figured out a way to build it that was practical and build more than just the one in the lab. Took the idea over to the IP department at Harvard and asked them if they cared if he got a patent on it, or if they would like to have the patent or whatever. They're like, what are we going to do with the speaker? These days they would be all over it. Oh yeah, we could use a speaker. We'll make some money on it. So, but anyway, so he got his first patent, excuse me, shortly after that, and then a second patent that had more practical stuff about how to build the transducers. And in '54, he gave a presentation to the AES in New York called A Loudspeaker Development. And in 1955, he decided he would start a company using this to make high fidelity, wide range tweeters. Wide range because they went all the way down to 800, which is not what most tweeters would do in the day. And while my mother was recovering from the cesarean from which I was born, my dad pranced into the recovery room and said, honey, I'm starting the company, which was, I'm sure, quite shocking. At any rate, as I grew up, I was sort of brought along with my father's stuff, because at that time it was all to do with the electrostatic speakers. I would accompany him when I was, above toddler, maybe 4 or 5 years old, and he was making the prototypes for what became the KLH-9 in a little lab he'd set up in North Cambridge. And I remember standing on the pedal of the shear press and riding up and down as he was shearing pieces for the transducers, for the woofers, for those things. I'll show you actually one of those. I hope to be able to do that. One of our customers traded, well, he brought us 2 pairs of speakers from which we could make one good pair of KLH-9s, and a third pair was one of these prototypes that had somehow been circulating around, and he had his hands on it. He just gave it to us. And so that might be fun to look at. It looks very different inside than the production version. For those of you who don't know, the KLH-9 was the first truly full range, fully electrostatic speaker. Quad claimed that, but their speakers don't really make bass, or at least the 57 didn't. And the 9 is flat to 40 hertz, so it really is a full range speaker. I don't know. It seems to me like that's a pretty good amount of history. The company went through a few different versions. In around '59, my father was friends with Edgar Vilcher, and he and his buddies were setting up KLH at the time. And they wanted the KLH-9, well, they wanted the full range electrostatic as the flagship for KLH, and became the KLH-9. So my dad basically licensed the technology to a company called Neshaminy, and they used the tweeters to make a range of speakers. Meanwhile, my dad went over to KLH with the 9, and I guess I'm answering this one now. So my dad went over to KLH as a VP of technology or something like that. I forget what his title was exactly, but he was working with them. Henry Close helped with some of the manufacturing engineering, making the thing a little bit easier and cheaper to manufacture. Meanwhile, he would get on interviews and say, "We threw every consideration of cost out the window. You know, these things are built as expensively as possible." Whereas, you know, that wasn't really the case, but they worked great. They went out of production because people were using huge amplifiers with them to try to make them louder, and they were damaging them. And KLH was honoring the warranty despite the obvious abuse of the speakers, and eventually they just said, let's just stop making these. We here get pairs of KLH-9s in for upgrade, sometimes for just refurbishment, but mainly we'll take them and do about 30 or 35 different things to them, including replacing the old tweeters with our new tweeters, and making just a whole bunch of changes that make them better. And more recently, I decided to make a new version of the 9 that I'm calling the 9.5, and I'll show you a pair of those in our test room later on. I have you on my phone, or I have me on my phone, so I can walk around with the camera reversed and show you some stuff around here. Yeah, so, a quick thing about, probably for the people who aren't familiar with what an electrostatic speaker is, hang on a second. This is one of our tweeter panels. I don't know if you can see, but it's basically 2 frames that are let sound through. There are 66 little wires on each side, and there's a membrane stretched in between them. The membrane gets a static charge, which is the electrostatic portion of the descriptive name of the thing. And these 66 wires get the alternating voltage that creates the force that vibrates that diaphragm. That's all there is to it. But what's great about this is that the force on the vibrating membrane is distributed evenly over the entire area. And that means you can't get breakup. The membrane does exactly what it's supposed to. And because it's so light, it's actually lighter. The mass loading from the membrane is less than the air loading within the audio spectrum. So that membrane is instantly doing what it's supposed to do at all times. The transient response is better than you can get from any other type of transducer. And if you damp the primary resonance, it's also critically damped, and the transient response is just as perfect as you would ever want. Maybe more perfect than some people would want. I know everyone has their own taste in sound, but for me, electrostatic is the best because it does exactly what it's supposed to. Does that seem a reasonable intro, or shall I go on?
That's great. That was awesome. I think we have, I think you did probably answer the relationship between KLH and Jansen. I think we have another question here. Have you considered ES headphones?
Yeah, well, it was supposed to be a 5-year contract, and after 3 years, my dad couldn't put up with Close anymore, and he quit, and we moved to Mexico, where my father pursued a contract with USAID, helping to develop more nutritious corn to help lift the more impoverished people out of their malnutrition in Mexico. So he didn't just do audio, he did all kinds of different things. And I myself was a product development engineer most of my life. And about, I don't even know, maybe 16 years ago, what would that have been? Yeah, 16, 17 years ago, I decided to stop working for other companies and thought about, what do I know how to do that most other people don't know how to do, as well anyway as I do. And I know some things that weren't really explicitly spelled out in the patents, um, that make for a little bit better transducer than all the other electrostatic guys. Not that I don't admire them; they're all good too. Oh, so yeah, so it was a 5-year contract as a VP, and he quit before that finished, and that ended that relationship. But he stayed friends with Edgar Vilcher. They stayed friends for their whole lives, really. Okay, this is my office. It's pretty dark in here, but I see my camera is able to compensate. Does that look bright enough on camera?
Looks very good.
Okay, good. So this is the first, well, actually the first model I'll show you much later. I could not sell it. It was too expensive. My company was new. There was no way. So once a dealer in New York told me, first he said, oh, a gigantic intimate speaker, because it didn't go very loud, as to his taste anyway. And it'll never fit under a window in an apartment. And I'm like, that's true. So I went through a few different prototypes and wound up eventually coming up with this, which we call now the Valentina. Originally, it was called the ZA 2.1, which it's a little bit too nerdy for most people. And I was finally, after many, many people told me that is too nerdy, I came up with a name. Valentine is the name of the daughter of a friend. She's a real cute kid, or she was. Now she's all grown up. So this particular one is active. It's got two, actually this one has 3 amplifiers built into it. It's got, it does everything. It has the DAC and the amplifiers and the preamp and everything built in. Everything is controlled from a remote. But there is I don't know if you can see this. There's a display on there that tells you that's preset 1. It tells you which input you're on, and come on. Okay, that's not the right one. Anyway, that's the interface. This particular one, the third amplifier, the first 2 amplifiers are for the electrostatic part and the woofers. The third amplifier is for these extra drivers that are on the 3 non-directive sides. These speakers are quite directive, and that's not good for everybody. What this speaker does is let you switch between the usual directive mode, which is about a 20-degree horizontal dispersion, maybe 5 degrees vertical, at 10 kilohertz. And what turning on these extra drivers does, they're full rangers. I know they're very small, but they go down to 200 hertz. They give the effect of an omnidirectional speaker, yet without such terrible image smears normally you'd get, because the sound to those is delayed. And also when they're engaged, and there's 2 different levels of, you can make them too loud for a room this size, you can make them about right. And the third preset is not on at all. But when you're in the sweet spot, switching them on, everything gets equalized so that the frequency response is about the same as it was in the sweet spot. So you get this envelopment, and you get this imaging pretty much everywhere in the room, although it's not the same as when you're sitting. All at the push of a button. If you want spacious sound, you just hit the button. If you want very intimate, you are there reproduction, hit the button again, and you're in the directive mode, which basically excludes most of the room ambiance. That's about it for what's in the room. Oh, I should give a quick mention to, well, you can't really see what this is. Let's see, hang on a second. This is not my invention, but this is the interface for the Bach system, BACCH. It's a 3D sound software that Edgar Schwery developed. It's really the only one that has absolutely no artifacts at all. This particular one is the least expensive. It just is software that runs on a Mac, in this case, a Mac Mini. This looks complicated, but it's not really. You get your crosstalk cancellation curves here and frequency response. There's nonsense on there now because I ran it without a microphone. Cool thing about it is you put microphones in your ears and it does impulse response measurements. So your head transfer function is completely accounted for individually. So the crosstalk cancellation can be as much as 20 or 22 dB, and it really is completely amazing the kind of sound you get from that. So we have more of those. I'll just give you a quick tour of the place. I have, by the way, a new 3D printer. Anyone who hasn't experimented with the latest in resin-based 3D printing really should try it. It just makes the most amazing things. I've been printing the bobbins for the new speaker here on this thing, and they just look like they've been injection molded. There's like, I don't know. This is what we had been using. It's an FDM printer, and it is, well, old-fashioned. That's all I can say. Various benches and states of disarray. Missing some things here. These are the Valentina has two of those electrostatic panels that I showed you before. They have to be in their own enclosure within the main enclosure, so the back pressure from the woofers doesn't wreck them. And these are two of those inner enclosures that someone's putting together. Electronics bench. This is a pair that came back from Singapore, all moldy, and we're completely redoing it. The guy that lives there traded his old pair in for a new pair that's active, and I imagine after 2 or 3 years it'll come back all moldy too. This is the membrane material that we use. See if I can get a piece of it off. It's different from what everyone else uses. It's not Mylar. Probably I shouldn't say what it is, but anyway, not Mylar, but yet very thin. The big difference between this and Mylar is you can probably hear this. It's not crispy. It's very supple. We were using Mylar actually for a while. That's what Mylar sounds like. Now, the advantage of having a supple membrane, well, it has two advantages. When there is a transverse wave, it gets damped. It doesn't crash against the support and crash back and forth and make really weird sounds. Another one is this stuff has a wide elastic, I'm not sure what the word would be, but supporting it on plastic stators, if there's a temperature change, that stator size changes a little bit, and that changes the fundamental resonant frequency of the transducer. But not with this material, because it's sort of, it has give. So when you stretch it a little bit and leave it like that, it restores the original tension. It's very cool stuff. Oh, also we protect the speakers with this stuff. This is, if I can get some of this off. It's pretty tough, as you can tell, but it is, I don't know, I'm gonna try to find a dark background here, so you can see if I can get it to come off my fingers. It's only 3 microns thick, and it's completely transparent to audio. So we use that as a particulate barrier. so the high voltage doesn't attract soot and whatever else from the air and foul up the transducers. It's really dark in here, but I see the camera's doing okay with it. So this oven we use for heating plastic for our vacuum molding. I know what. I should turn on the light. Oh, this is an ancient Jansen speaker. This was made by Neshaminy. Someone dropped them off here for us to get working again. That is a real old school woofer there, but it's the original woofer, original surround, still works fine. They don't make them like that anymore. All right, let me go back over here. So here's an example of one of the vacuums that I made on the 3D printer. A little hat thing. I'm thinking of using. This is the bench where panels are made. This is a bunch of stock of our stand mount speaker. Anybody who wants a really fantastic stand mount speaker, please call. We've got inventory. This is our wood shop. Do a lot of the prototyping in here and make some of the parts for the speakers. Most of the speaker basic parts we have made elsewhere. That is the wooden parts, like these are the plinths, but we do all the finishing here. That's the semi-portable paint booth. So we have a customer who sent us 2 pairs of KLH9s, and he wanted maple frames. And then when we got his speakers, I realized they're just perfect. We've got them sort of hidden back here. I just couldn't stand to take them apart and throw away the frames or whatever. So we ordered up the new frames. We have plenty of other stuff to build his speakers from, and he was cool with that for a discount on the total. But as long as I had these frames already being made, I thought, well, I could put something better into such frames. And this is the result. We've got 6 ceramic cone 8-inch woofers and a 4-foot long synthetic aperture line array electrostatic. It's not going to be quite possible to see what this really is because there's damping material on the back, but I don't know, can you see through the grill that there's some vertical stripes? That's actually a question. Tony, can you see that this transducer that's hiding behind this grill?
Yeah, I can see that. Yeah.
Okay, so what makes it a synthetic aperture is that this center stripe gets the direct sound, and then flanking pairs get successively delayed sound. So it's as if this thing were curved backwards a little bit, like it's a cylindrical section. So this thing gives 20 degrees plus or minus dispersion at 10 kilohertz. And in fact, should not be aimed directly at a person like our regular speakers are. And so you get the dispersion of the center stripe, but with the loudness of the entire area, which is 8 inches wide and 4 feet tall. And this thing really sounds good. And it's about 9 or 10 dB louder than the KLH9 at its maximum, with a full, 300 watts going into it. Yeah, this room is the one that we do all our penultimate testing. We do the final testing in my office, but yeah. So everything happens here. That's paper for background, lighting to do all our own photography. These are some original KLH9s. We have a lot of them around, but they're all in pretty poor shape. I'm looking for the ones that have the special guts, but I'm not seeing them. That's another pair of old Neshaminy Jansens. Oh, I guess I didn't finish talking about that. The changes that occurred over time. So when my father went over to KLH, he'd licensed the technology out, so he didn't any longer do anything with electrostatics for quite a while. After Neshaminy decided that the future was computers, they stopped making the electrostatic stuff, transferred all the assets over to another company called Jansen Electrostatic, initially called Soundmates, I think, something like that, in Minneapolis. And they made a whole bunch of new versions. And they even redesigned the tweeter. It conformed to the patent, but it was, in their opinion anyway, cheaper to make. And it worked perfectly well. Maybe this one is easier to see. Nope. That is a prototype set of delay filters. These coils, hand wound here, have an enormous amount of inductance for an air core coil, but air cores don't make distortion. Okay. I guess I'm not as prepared as everyone might have hoped. Yeah, I think we're done in here. I have another earlier version of that transducer I can show you that doesn't have any covers on it. That would be this puppy. This is a 7-segmenter. And after testing, I realized I didn't really need 7, 5 is enough. And 5 fits into a KLH9 frame, half the frame. So we've got, again, wires on both sides and a membrane in the middle. Same basic idea. Yeah. Okay. I wish I had a stand mount I could show you, but they're on the website. They have, instead of 2 panels, they have a single panel and a single woofer. These are 8 inches. The stand mounts have 2 7-inch woofers. One of them is in back. It looks like it only has 1, but the one in back is actually a second woofer, not a passive or port or anything like that. So it goes really deep in the bass. Very small speaker. Okay. I don't know.
Well, maybe you have time for a couple questions here, since
Yeah, let's do
a
that.
couple people, going back to the KLH9, that's a full ESL speaker, no hybrid approach. Is that correct?
Correct. Yes.
Yeah. So full ESL, and you said it went down to 40. It's flat to 40 hertz.
Yeah.
Okay. Another question that came up is, have you considered, I guess, electrostatic headphones as an option?
I have developed electrostatic headphones. The problem was well, first of all, I need a Kickstarter campaign to finance putting them into production, because that's going to be very expensive. So flip this around. This mess here is parts of one of my prototypes. These will be the first electrostatic headphones that are completely self-contained. And they're, again, like all my other designs, hybrids. That is, they have a woofer. The reason it was possible, the way it was possible to fit everything into the cans is by having a crossover at 250 hertz. So the transformer for the electrostatic portion doesn't have to be huge. And I developed a battery-powered bias supply that monitors the voltage, and each time the voltage droops to a certain level, it burps a little more charge onto the membranes and then turns itself off, goes back into monitoring mode. So the batteries last a really long time. And they're rechargeable through the same jack that you would connect your source from. And they're sensitive enough to drive from a phone. So you don't need any box that you plug into the wall. You can just plug them into your phone if you want to, or if you want a little louder sound, into a portable amplifier or portable player. And yeah.
And so this wouldn't need a dedicated electrostatic amplifier. You could basically
Nope.
run it off anything. Awesome.
Off of absolutely anything. Yep. And go anywhere with them. You're not tethered to the wall like you are with most electrostatics.
Sure.
But the main problem after the first Kickstarter campaign failed, it was one of the beta testers was able to bottom out the woofer. I don't know how he did it, but I figured if he could, somebody else could. So I went on a long search for a new woofer, and I finally found one just late last year. So once I get this new 9.5 thing into production, I'm back on the headphones, and they should be, I hope, in production by midsummer to late summer.
So the 9.5, that was what you were showing us in the shop with the line array woofers and then the panel as well. Is that correct?
Yep.
Yep. And that's not is that a passive speaker, or is that also active?
Yeah, that's passive.
Okay.
Someday maybe also an active version.
Yeah. So what got you on the path to an active speaker? Was there any method with that? I mean, I know that they're more popular these days than they used to be, because typically living spaces and things like that are getting smaller and smaller. But what led you down the path? I know we spoke probably about 3 years ago at an event here in San Francisco, and you were talking about it, but I hadn't actually seen till now that you had one in production.
Yeah, it's actually the second version. We're using different amplifiers than we used to. We were using an Italian amplifier, and now we're using Hypex amplifiers, Encores. There are two of their 500 watt amps in the floor standers and two of their 250 watt amps in the stand mounts. What got me onto making powered speakers, I mean, my very first design, I forgot to show that to you in the other office. Anyway, my first design was an active, and it was before people thought that you could get high fidelity from an active speaker, or dealers thought you could sell an active speaker and still make money because of, cables. Cables are a big profit center. You can charge a lot of money for copper for some reason. At any rate, I just know it's a great idea. You can build in the equalization. You have amplifiers that are optimized in every way. To the transducers, there are no speaker cables, which they can have an influence on the sound, and really never what you would want. They're not a good way to do tone control, for instance. So yeah, so the actives, I saw that. I'll get back to the delays in a sec. In an active, you can put a delay between the two sets of transducers and time align them that way. You can do the crossover digitally and have it work exactly like you want without any parasitics influencing the performance of the crossover. And it's so much easier, actually, from my point of view, to do it that way, because when you design a passive crossover, it just never works the way it's supposed to until you work on it a lot to get it just actually to work like the way you would have hoped. With digital, it's just, you monkey around with a user interface on a graphical user interface and do some testing and do a little more monkeying around, and ta-da, it's great. Also, I think there's a trend toward, and this wasn't the case when I first started enjoying the idea, but a trend toward plug and play, that things should be minimal and easy to deal with. And actually, my system at home is just a pair of actives with a Bluetooth receiver and my phone. That's the whole thing. No pile of equipment. It's just simple and easy and doesn't take up space. The amplifiers are switchers, so they don't make a lot of heat. They don't use a lot of electricity. I don't know. I just think it's a nice way to go. And so far, it seems to be well accepted because we rarely get an order for the passives. Almost everybody wants the actives.
Great.
Okay, so back to that
Delays.
question about,
Yeah.
sorry?
With the delay questions here, a couple of them.
Yeah. They're analog. They're actually done at the after the output of the step-up transformer. One of the things about electrostatics is it takes a lot of voltage to move that membrane. There's in the case of that particular transducer, there's a 4,000 volt polarizing charge on the membrane, and then plus or minus at least that much at a peak to move that membrane. So who wants to make a system with a different transformer for every set of those segments on the transducer? Not me. So those delays, much like in the Quad 63 and its subsequent designs that all have different numbers and almost the same stuff inside, they're done. It's done analog on the high voltage that drives the membranes directly. I mean, drives the stators. An important point is you don't want to drive the membranes. It's important to drive the stators, and that's because if you want to drive the membrane, you need a very conductive coating, and if you do that, then the electrons can chase the place on the membrane that's closest to the stator. So you wind up with a lot more force, the force changing a lot with the position of the stator. I mean, the membrane. Sorry, it's been a really long day here. And when you put the stationary charge on the membrane, it just stays put. The approach is to use a very high resistivity coating so that the charge just stays put as the membrane moves and doesn't try to go toward the middle of the membrane when it's moving toward one of the stators, and then running away when it's moving toward the other of the two stators. So I guess I added a lot of information, but the basic answer is those are analog delays. They're just simple. They're called lattice delay somethings. I forget. There's a technical term for them. I always just call them all pass filters. But to do that in analog, you have to have this lattice thing where you've got, in this case, crisscross capacitors and series inductors. And what happens is, if you were to go through, like there's a frequency at which the current starts to go across instead of straight through, and that causes a phase shift with frequency that amounts to a time delay rather than an amplitude shift with frequency. It's a phase shift, and that's how the delay is made. It's very cool, but it seems obvious once you've seen it, but I never thought of it. I had to see it.
What's the typical, I mean, I guess, what is the crossover point in the active speakers between the panel and the woofers?
Oh, the regular models are at 500 hertz.
Okay.
The new 9.5 is at 200.
And then it looks like there's a subwoofer that was in there next to the active speaker. Is that correct? Or what is that?
You noticed. It's just
somebody else
prototype.
noticed. I mean, I did notice, but somebody else brought up the question.
Okay, that's just a little prototype that I made a long time ago. And the reason it's in here is because somebody asked me if there were a way to drive a sub from our active speakers. And I thought, nah. And then I thought about it some more. And in fact, it's easy to do. Because there are 5 completely independent inputs and outputs on those speakers, and 3 of them are digital. And one of those digitals is an AES, which nobody uses except in studios. It's a differential version of SPDIF, copper, wired SPDIF. And all you have to do is single end that and connect it to a DAC that can take a SPDIF input and run that to the sub. It's simple. It works great. You can do it on both sides, and it just gets the signal from that side. And yeah, so I made somebody happy with that. Hope I'll make a lot of people happy with it, because I might just build that converter in the future, because I don't know of a single person who cares about the AES input and output. It has an output too.
Looks like we had a question. You might want to see if you can, it's a long question, but it's in the chat. One of your customers, Rick from Phoenix, who has your ZA 2.1s, and looks like he wants to try to raise them by 18 inches. So it's asking about a stand that could adjust both the incline and height to accomplish this, or is there a better solution?
Yeah, hi. We have a version of okay, what creates the tilt is there's a little riser in between the plinth and the cabinet. And we also make a straight up riser. And that would just orient the speaker vertically. And then 18 inches might be just about right to, have a straight up vertical speaker instead of a tilted back one. I think it's a good idea. It makes it so that the frequency response isn't determined as much by the distance from the speaker. When there's a tilt, the sound is aimed up a bit. By the way, the image isn't from the floor. It sounds like the image is going in a big arc above the speakers, even though they're on the floor. I'm not sure what would happen once you put them up. I did check it once I think Keith has his speakers up. Hi, Keith. Up off the floor on he has a speaker, a stereo stand. It's really, you have to put the speakers up on the sides of that stand. So he was the impetus for that straight up arrangement. We could potentially make risers of any angle. I could do the geometry to see what at 18 inches that should be. We're adaptable.
The 9.5 in production, or when is it due for production? Or
I'm still designing it. I took a pair. I took a pair of them to the Capital Audio Fest.
I heard about that. Yeah.
Yeah. I just wanted to see if they might have any legs at all. If anybody might be interested. And like 3 people ordered pairs, and I was predicting 3 or 4 months before they'd be in production, and they're waiting. I'm almost done with all the designs. I'm still laying, I don't know if you could tell by looking at what I showed you, but all that stuff is, it's hot melt glued together. It's all hand wired and hand wound and everything else. It's not ready. And even electrically, it wasn't ready. The delay lines that I had wired up for it, I hadn't quite figured out how to make them work right yet. I was really trying to just do what it appears that Quad is doing, and I don't see how theirs will work either. But finally, I discovered what the missing ingredient was, and all of a sudden, those are working really well now. But at the time, they were rather beamy. They had about, a 2-foot listening width, and now they have, all across the room listening width. So I think another couple of months and they should be in production.
Great. That looks like a very nice speaker. Now on the Valentina and some of your other floor standing models are basically closed back. This one appears to be an open back. Is that correct? Or
yeah, it's completely open baffle. Well, what is the reason? I absorbed quite a bit of the back wave from the electrostatic. First, there's a damping layer to make sure that the membrane resonance is critically damped. And then I put some fiberglass behind that, and then sandwich the whole thing in with a perforated metal back that is missing from those prototypes at the moment. The main reason I wanted to keep them open baffle is for the bass. An open baffle design excites the room modes less because the sound comes out in more of a figure 8, because the lower bass gets canceled. Because it's omnidirectional, the bass goes in the front and out the back and in the front, and out the front and in the back. So there's very little sideways dispersion of the bass. And so it comes out sounding a lot more natural than even a closed box. Our other designs are sealed, yeah. And that's the main reason for preferring a sealed box, is that the transient response is better than with a ported speaker. Ported speakers use resonance to deepen the frequency response, and that resonance amounts to a large group delay and a tendency to mess up the transient response. A lot of people prefer it, so I'm not knocking it. But if you want to match an electrostatic, which has extremely fine transient response, to a woofer, you really have to use a sealed box or an open baffle. The open baffle works because of the inherent damping of the front to rear cancellation, along with choosing woofers that are well damped.
Looks like we had a question pop up on the open baffle woofers. Are they equalized to compensate for the dipole radiation?
No, it just worked out amazingly. Having them in a line like that self-corrects most of that. And since they cut off at 200 hertz, they're not operating in the range of frequencies that a dipole normally needs a lot of help with. One thing I do, though, is the frequency response, completely unequalized, has a huge hump. It's like one great big hump from, subsonic out to 200 hertz. So I suppress the middle of that hump, and the effect is to deepen the bass, and overall the sensitivity of this arrangement with that hump pushed down matches the sensitivity of the electrostatics, and it just worked out very luckily, I guess you could say, fortuitously.
So I guess speaking of the sensitivity, obviously the active speakers, you don't really have to worry about any of this, but you do sell some passive speakers. How sensitive are they? What type of amplifier complements usually are good for the speakers? Maybe just talk a little bit about the passive design and how you match that up.
That's a good question. The stand mounts are about about 83 or 84 dB sensitive. And I measure sensitivity at 1 watt with pink noise. If I see a lot of sensitivity measurements, like using a sine wave at like 1 kilohertz, and that doesn't necessarily well represent what the speaker does overall. So with pink noise, you get the whole speaker going, and you get a pretty good idea on C weighting what you have for an actual sensitivity at 1 watt. So the stand mounts are around 84, and the floor standards are around 87 with the same amount of power. Those 9.5s, though, are pretty insensitive. They seem to be running around 80, 81 dB. I haven't completely finished them, so I'm not quite sure what we'll get, but my latest check, it looked like right around 80, 81 dB. But they'll take 300, 400 watts. So it's not really a big deal, in my opinion.
What's the nominal load on the speakers?
5 ohms.
5 ohms.
They never drop below 4, and they never go up above about 20, I think 21 ohms. They're very benign load.
Tube amps don't seem to need to apply, is that right? It seems like they will require some current.
Yeah, well, yeah, you'd need a lot of tubes. But they sound fine with like 40 or 50 watts. They just don't go very loud.
Sure.
And in a small room, they work fine in a small room. I mean, despite their enormous size. So, you know, they would go loud enough for many people with just, you know, 40 or 80 watts. But that does rule out my favorite tubes in most cases, which are EL34s.
Mhm.
Not a fan of the KT series, but
Right.
yeah, whatever.
Two of us. But what, you know, you mentioned the headphone. That's, you know, once you do your 9.5 production, you're going to move on to the headphones. Anything else on the horizon? You know, what's the
Yeah.
future of Jansen Audio?
I have a bunch of ideas. I just don't know if I'll ever complete them. There are a bunch of back burner projects. One of them is a single box that incorporates the Bach 3D crosstalk cancellation scheme, but with sort of a, I don't know, maybe 4 or 5 relatively generic head transfer functions built into them, so people can find one that gives them the full, you know, room sound, you know, surrounding those. That gives a complete surround sound impression. You can even hear the room ambiance behind you and everything. And that would be like a single box with 2 electrostatics and 1 or maybe 2 woofers, all active, with probably Bluetooth and maybe a Wi-Fi receiver built in, and the whole thing affordable, like 1 or 2 grand. So like a very advanced boom box, I guess you might think of it as. There's also a completely transparent speaker that I've had on the drawing board for years and years. It would operate very much like the 9.5, but look like it would look like it was made of glass. You would be able to look right through it, and it would just be self-supporting. I was calling it the Glass with 2 Z's back when I was working on it a lot. That might be coming someday, but that would be a very expensive speaker, probably in the 60 to 80 grand range a pair. I'm not sure that's really something I'm branded to sell, but never know until you try.
Looks like we have another question here. As you can tell, we have a fairly technical group, and that's what one of the things I like about the group is they're pretty smart technical from a technical perspective. What are the specs of the D2A converters? I guess the digital to analog converters you use in the active speakers.
2496 internally, basically, but they get the signal gets down converted to some really odd frequency that I can't remember now. It's close to 96, but it isn't 96. It just has to do with the converter that's in there, that the chip likes to run at something strange like 92.7 or something. But yeah, it's high enough resolution, I think, and that everything is all built into one card. The analog inputs are actually digitized. Everything has to be digitized because of the equalization, and the crossover is digital. All the processing is digital before it goes out to the amplifiers. So I think it's pretty harmless having that A to D in there. That's probably an even more concerning factor, probably, for somebody who's asking about the D to A converter. But having all that circuitry on the same card without interconnections and whatever else, and the potential for mismatch, that all the conversion chips are AKs. I can't remember. It's a Japanese company's name. I can't recall, you know, the full name, but they're the pretty high up spec'd AK converters. Oh, and of course, analog devices, the DSPs in there.
Right. Anything else? I mean, we can open it up for questions, like from the group now, like just a conversation. I'm sure a lot of people would like to talk to you and meet you.
Sure.
Anything else you want to add or talk about?
No, I I think I'm all out of steam here. I'll need some external support there for the steam engine.
Yeah, no problem. Well, if anybody wants to unmute and talk to David and ask him any questions or seek out his sage advice, feel free.
All at once, please.
Yeah, all at once too. Yeah, that'll work.
David,
Yes, Bernie.
Bernie Heater.
Yes.
What were some of the best electronics for the KLH9 at the time when they were on the market? I noticed that you said that people were blowing them up with their 300-watt amplifiers.
Yeah. Not an Ampzilla, that's for sure. The best amplifiers were the Marantz EL34 based amps. They were, and just the whole Marantz line really seemed to be the best. Although I think the Scott receiver was probably the best one of the day. The Scott tuner. We had Marantz 5 monoblocks in our house to drive our 9s. And I think the 10 preamp and a turntable my father put together himself. So yeah, the 40 watts is just fine for those. 16 ohm tap, those are 16 ohm speakers. They're almost flat 16 ohms.
Amazing.
Can I ask a question regarding the rear radiation of the Valentina?
Yes.
So are you heavily damping that too, even though it's a sealed enclosure? So that the reason I asked the question is because there's a former speaker designer in the Bay Area named Brian Cheney who died several years ago, but at his house, he demonstrated to me prototypes of a mid-range or tweeter that he was experimenting with the amount of damping. And when he had too much reflection from the enclosure, it sounded just like distortion. I guess because sound was bouncing back and forth between the tweeter sub-enclosure and the tweeter membrane.
Uh-huh. Well, here we have one of our interior enclosures. It's just the right depth to be able to accommodate just the right amount of absorptive material to kill the back wave on its round trip to the back of the enclosure. So it's about 4 inches deep at maximum, and it's just fiberglass in there. We tried some other things, but fiberglass seems to work best. And yeah, it's completely absorbed, so there's no cancellation or reinforcement from the interior reflections. Also, this stuff has a nice effect on the damping the primary resonance of the membrane as well. So it serves two purposes.
Thank you.
You're welcome.
I have questions. With regarding the 9.5s, the amplifier I currently have is a 300 watt per channel amplifier, but in the 4 ohms, it's rated at 600 watts per channel. If I was interested in a pair of 9.5s, would I also be interested in a less powerful amplifier?
No, you'll be fine. You can't hurt him.
Yeah.
Not with 600 watts. I wouldn't put a kilowatt on them and drop the needle on my turntable. But
No problem there. Now, what are the opportunities for me to hear the 9.5s?
Well, not a lot. We're going to have a pair here. Oh, actually, I'm not sure if he'll be entertaining guests, but I'm planning on sending the first production pair to Robert Green down in the I think he's in LA.
Orange County, yeah.
Yeah, in Orange County. But I'm not sure that's, going to be very expensive to do that. These things are not cheap to ship. They're heavy and big. So I'm not sure. There's a reviewer right here in Ohio who I think might be appropriate as well. The nice thing about Robert is his credentials. He's reviewed our speakers before. He's a mathematician, he's a violinist, and he knows what he's talking about. And I'm an engineer, and I'm not just whatever. I have a physics background, and I just like his approach. Very unromantic. So what I'm thinking is what I did with the previous models is, people buy them like, sight unseen, basically. And once enough people have a pair, there'll be some place to go hear them in most areas. So yeah, audio shows are another way, although I haven't done a California show in a really long time. I would like to. When Richard Beers moved his THE show to Orange County, I did that show a couple of times, but I don't think I've been out there since then.
Are you going to display them or entertain people visiting you there at your facility?
Oh yes, definitely. We'll have a pair here. Yes. Do you have any other reason to come to Columbus?
Yes, I do. I have reasons to avoid Columbus.
Oh.
No, that's because
Oh.
it's where I spent the first 20 years of my life, and I'm not nostalgic about it.
No, well, it's a lot better than it used to be.
Okay.
Like my wife and I lived in New York City before we moved here about 23 years ago, and it was a shock. But nowadays there's great restaurants and there's a music scene, and it's, and the air is still clean, Leslie. So yeah.
Okay, I'm from the Wisconsin, so
Oh, it's really clean air. Okay. Yeah.
yeah, I have a fondness for the Midwest.
I can't
So.
compete.
So what shows
Alrighty.
are you going to, David?
I'll be doing the Expona in April, and I'm
Oh,
not
okay,
sure
that makes
about
sense.
other ones since after that. That's a nice one. I can drive there in 6
Mhm.
hours,
That's a great
can-
show.
Yeah, it is. It's greater
Mhm.
than ever this year. They've got like 120 exhibitors this time. It's amazing
we
number of rooms.
We went last year. It's the best show I've been to. It's overwhelming. You can't get through everything, certainly. in a few
No,
days.
and it'll be even harder this year.
Yeah,
So I didn't see you in my room, I don't think.
I was zipping through a lot of rooms.
Yeah.
But
Yeah.
yeah, we'd love to hear the product. What are the price points on the powered speakers that you were talking about?
Okay, well, let's start with the passives. They're the same speaker, but with amplifiers.
Uh-huh.
So the passives are just under 5,000 for the stand mounts, just under 10 for the floor standers. The 9.5 introductory price is 19.5, and I still don't really know my costs. My fingers crossed that my rough calculations were close enough that I won't lose money at 19.5. They're expensive to build. And then adding the amplification to the stand mounts is an extra 3,000. So you get the amps and the preamp and the DACs for $3,000, and it's an extra 3,500 for these floor standards.
Yeah,
Yes,
so
to be
actually
determined.
it's your whole system, basically.
Yeah,
Yeah.
entire system in one pair of
Mhm.
boxes, plus a phone. Actually, the pair that's in my office has a Wi-Fi receiver in it, so you can just run them from room on your LAN.
That's
So,
great. There's a beauty to simplicity.
I think so too. It's a little bit more complex internally, but then the system becomes for the owner very simple. Yeah.
I'm sorry.
Oh, I was just going to say, but what would I do with all my extra time if I wasn't constantly connecting and disconnecting and reconnecting and switching out components?
You would
I have so
hopefully
much
be
extra
enjoying,
time in my life.
you would hopefully be
I know.
enjoying your music more.
I know.
Yeah.
I do
Playing
so
it
much.
really loud and, you know.
I do that too. Believe me.
I
I
have
almost,
I have a pair of Jansen Electrostatic Z412 HPs that I
Uh-huh.
bought probably in 1973 or 1974 that
Very
are, although I
good.
don't use them often, they're still in service and they still work fine. Who actually made those if it wasn't your father's company?
Well, it was his licensee, Electrostatic, Jansen Electrostatic. That was, I forgot his first name, a guy named Kluwer ran that along with Roger West, who then went and started Sound Lab. So yeah, those were made in Milwaukee, or Milwaukee, I think so. No, Minneapolis. I always get these Midwestern states mixed up, and cities. But anyway, yeah, those were really a lot better than the ones that Neshaminy made. I couldn't believe how bad these ones were that actually that we got in for upgrade or repair. I couldn't simply repair them and leave them the way they were. So I put in new crossovers, and now they sound like not bad. But the Jansen Electrostatics, like the Z412 HP, really good speaker. Yeah.
I like it.
Yeah. Do you know what the HP stood for?
No, I don't remember.
Harry Pearson.
I was going to say that. I kind of.
You should have chimed in.
I mean, it was
Yeah.
it was a wild ass guess, but I was going to say that.
Why does it stand? What is the homage to Harry Pearson and the speaker?
Well, he wanted to do a review, and everybody knew that he likes a lot of bum bum. So that one was designed with some extra bass response.
I always thought it stood for high power because the 412 HP differed from its next version down insofar as it was biamplifiable.
Okay,
So I thought it meant high power because it has the straps to connect the woofer and the treated wire connections on the back. Well, I stand corrected.
Yeah,
David,
not many people know that one.
David, that speaker, that you said the last name of one of the designers was Poor.
Kluwer.
Oh, with a C.
Don Kluwer, no, Klewer. It looks like Cleaver or Cleaver, but yeah.
Okay.
Cleaver. Actually, I think he pronounced it Cleaver. I don't remember. He came to our house once. He brought his updated version of the tweeter, and I was in high school. I was a mean kid, and he was talking about, oh, this is the best material ever. He whipped out a couple of these stators, and I'm like, oh, really? What's so cool about it? And I like broke it in half to see how strong it was. And then I go up to my room. That was my contribution to the day. And I drove him to his hotel.
So those tweeters, I guess in that era of Jansen design, were they made in-house, or I thought they looked very familiar to RTRs, or they, you know?
Yeah, the tooling to make the stators, you know, they were injection molded by a company in Concord, but you know, they didn't do the injection molding at any of these companies. Nobody, I don't think, does their own injection molding anyway, but the stator wires were applied, and the whole transducer was built other than the injection molding in-house. Yeah. It was just done a little bit differently for the new design that Don Kluwer and Roger West put together.
And then for a long time, there was the tweeter element that was sold to work with other speakers like an AR1, I believe, possibly. Is that correct?
Yeah, the AR1, there was a special version, the AR1W, that had no tweeter in it, that was made specifically to go with that array. And I have multiples of those things around here, sitting around and waiting for me to do something with. These are two such, it didn't switch to the back. Come on, switch around. There we go. So there are two of them, one stacked above the other. Each has 4 of the original Jansen tweeters. They're very, very sensitive, actually. They get super loud with 20 watts. But they cross at like 800 or 900 hertz. So your woofer better be a really good one. There.
David, what are your reference tracks that you typically use to voice your speakers?
I don't really voice them. I try to get them to run reasonably flat in room and not have any peaks or major dips. Peaks are the things that sound really bad. And I play all kinds of music on them to see if I like the sound. All kinds, except, well, sometimes even hip hop, but not country, not country pop. I think that's where I draw the line.
You know, I can't play my Johnny Cash on your speakers.
Oh no, I love Johnny Cash.
Oh.
He's not country pop. He's country.
Yeah.
Or country folk, whatever.
Mhm.
I thought he had popped a few in his day.
Okay.
David, if I were to send my original, the CA 2.1s, it's got this single side firing tweeter.
Yeah.
If I were to send it, it looks like $2,300 to move up to the 8-inch woofer with modifications and a crossover.
Yeah.
Would that include that shim that's flat so I could take the incline out?
Sure.
Okay, I gotta check and see if I get the boxes, and I'll email you.
Okay, sounds good.
And David, if you decide to do another Kickstarter, you should send it to us. We'll distribute it for you. I think
Oh, that would be fabulous.
we'd have a receptive audience.
It's like I was trying to rabble rouse, I got a bunch of people interested from our own mailing list, and some of them actually I haven't even given all of them their money back. Some of them are still waiting after 3 or almost 4 years for me to finish this project. But yeah, the only people who really signed on to the Kickstarter were the ones I almost like personally talked to. It was like 25 people or something, and I needed 100, 150. So yeah, it bombed. But thank you. I will definitely ask you to help me.
Well, we always like
Hmm?
to support new innovation in the audiophile world. So
Cool.
I know I've done some of these Kickstarter campaigns and I still haven't gotten the levitating turntable thing. That one didn't work out very well. But you got to support people's dreams. So
Well, I'm told that I did it wrong. You have to spend a couple of months with all this publicity stuff to get a bunch of eyes onto the project when you actually launch. And I didn't do that.
okay, well, any help we can give you,
Thank you.
we're
I'll
very
take it.
supportive. So
Looks like we had a question pop up in the chat. So looks like someone wants to know the magnitude of the frequency response ripple of the LC delay line. It's Greek to me, but probably means something to you.
Let's see. I don't know. I don't think it's much because it's well damped. But yeah, the frequency response ripple there's probably some there. It's certainly not audible. It would be an interesting thing for me to find out. If you email me, I will try to remember to send you a plot if I ever manage to produce one.
Well, I could say, David, it's my birthday. You could send me a pair and I would be very thankful.
I would like that.
5.5.
Your thankfulness is worth anything to me.
priceless.
Priceless. I'll mail them off tomorrow. I hope you don't mind if they're like this big 3D printed speakers.
Well, I could set those little ones on top of my existing speakers and pretend.
Yeah. We'll paint them up nice. They'll look just like a real speaker.
All right, then I can play my Johnny Cash that way.
I don't think his deep voice will come through them, but you can try.
Okay.
Yeah.
Does anybody? Let's see.
Who, by the way, asked that question about the ripple, passband ripple? Because that is unusually well-informed question.
I did.
Okay.
I mean,
Are you-
I'm a former double E myself, but
Ah,
not for I only worked as a double E a couple of years after graduating from college. And not analog either.
well, sounds like you remember a couple of things.
No, I know that I mean that the more stages, the more LC stages you have, the less ripple you have, right?
It
Because
depends on,
otherwise it's just a big you know, each LC pair is tuned to a different frequency. That's how you get a passband kind of filter with wide bandwidth and phase shift.
well, I'm just using a single stage per delay, and there are 2 delays, and I'm terminating it with a resistance.
Oh,
Yeah, so you wind up with a very linear response in phase, and I don't really think there's much much amplitude ripple in the frequency response.
okay.
But
I didn't think about the resistor part.
Yeah, yeah. One of the mistakes I made with the original ones was I was trying to drive these capacitances with these LC delay lines, and it just barely worked. And another thing that I can't believe anybody didn't notice and object to was I was using ferrite core inductors. And imagine the amount of distortion those things were introducing, but it wasn't really that evident in the sound. So people were impressed. But now with the air core inductors, there's absolutely zero distortion. It's fantastic.
And do you remember the scandal involving the original B&W 801 where the
No.
oh, so the inductors in the crossover were parallel. And so they were coupling each other strongly. And apparently B&W they breadboarded it and didn't test the actual configuration of the shipping version. And Stereophile and other magazines found that the frequency response was way different than what they had measured. I mean, what the manufacturer had measured.
Uh-huh.
So people were actually experimenting with using tin cans to shield the inductors, but then that changed the inductance and it was a mess.
That's just dumb.
So if your inductors are perpendicular, you don't have that problem.
Yeah. Well, ours are like pancake inductors that are parallel to each other. They're laying flat at a good distance away from each other. I don't think they
Right.
couple.
Right.
We do use iron core inductors in the crossover, but they're both, crossed and kept well away from each other, so it works fine. It does what it's supposed to, and we do measure after we make a production version.
Right.
I did once ship a pair of speakers with the phase wrong on one side. I was in a big hurry. That was bad. But, once. Much more careful since then.
Okay, does anybody else have any other questions? Think we're good? Yeah, we usually go about an hour and a half So,
You've hit your mark.
yeah, we really appreciate your spending time with us and showing us
Oh.
your lab. It's a wonderful thing to
Great.
see.
I
And
appreciate you having me, and I hope the huge mess that I showed you will not reflect badly upon my company.
Trust me, Roger's shop was a lot worse.
not to
than
worry. Yes.
Oh,
No.
if
No.
I could put in maybe a slight plug for David that he would be too modest to do himself. He is a regular participant in Robert Greene's listserv. And so if anybody wants the opportunity to communicate with David and also with Robert after Robert reviews that initial production version, joining the listserv is a good way to do that. And it's on the, oh gosh, I'm trying to remember the name of the chat forum. David, Groups.io.
Mhm.
So if you go to Groups.io and look for REG on audio, you can subscribe.
That's where REG on audio went. He had a nice little website at one time with some really good information on British monitors and things that I used to own. And that site went down, and I'm like, wow, I should have saved all those documents.
I think he may have archived it somewhere. I think it was being hosted by Yahoo or something, so he lost it when they went down.
I see.
That's what happened. Yeah.
Yeah. Okay.
Hmm.
Well, maybe next time I see him, I'll ask him. But anyway.
Okay. And if you are ever interested in teaching a class, we're always looking for teachers too for our school. And you could do it virtually. So we're looking.
And I would be virtually good at it.
Yeah, we're trying to bring together the great minds to pass on your knowledge to future generations of engineers and designers. So
yeah,
so
I guess if I'm going to do it, I better do it before the croak, right? But that's, I don't know. Thanks. I'm not sure. I'll think about it.
okay. Okay, no pressure. Okay, well, if nobody has anything else, then again, thank you very much, David. Thanks everyone for joining us on a fine Saturday afternoon and evening, depending on where you are. And be careful out there with that nasty weather that we're all having. It's great seeing y'all.
Take care. Thanks, David.
Thank you.
Thank you,
Thank you,
David.
Dave.
Thank you, everybody. Nice
Bye.
to be here.
Thanks, David.